Okay, so we can look now at tree diagrams, and actually, rather than just listing outcomes, we can actually put probabilities on the branches. Okay, so let's have a look at an example. Okay, so I'm going to throw a die, and I'm just looking at the outcomes of sixes. So I toss a die twice, find the probability of getting 1 6. So let's have a look at how the tree diagram would look. So there's only two things that are happening. It's a 6 or it's not a 6. Okay, that's the first toss. And on the second toss, it's either a 6 or it's not a 6, or it's a 6 or it's not a 6. And that's the second toss. Okay, now that's the branches would be 6 and a 6, 6, not a 6, not a 6, and a 6 and 2 nots. Okay, so they're the outcomes. Don't forget, we could have called not a 6, we could have put 6 with a dash above it. So this could be 6, 6, 6, 6 dash, 6 dash, 6, and 6 dash, 6 dash. So they're the outcomes. Now let's have a look at just adding some more information. The chance of getting a 6 is 1 on 6. So the chance of getting not a 6 is 5 on 6, because all of them have to add to 1. And then same thing again. So rather than having 4 outcomes and each of them being a quarter like we had before, now we don't have equal outcomes, because we've got a chance of 1 over 6 and a chance of 1 over 6. So we multiply the probabilities. So the chance of getting 2 6s is 1 on 36. So we don't have quarters anymore. So this one, 6 not, will be 1 over 6 times 5 over 6, which is 5 over 36. And then the not and the 6 is that number times that number. So that's 5 over 36. And then the last one will be 5 times 5, which is 25. And then all those numbers add to 1, because they're all the things that can happen. Okay, so copy that and then come across and we'll look at another example. Okay, so this time I've got a bag with 4 red balls and 3 white balls, and I'm going to take 2 balls out of the bag. Okay, and this time the first ball is being put back in. Now the reason we're going to put it back in is because then the probabilities don't change. Okay, so let's start off with the first ball is taken out, and it's either a red ball or it's a white ball. Okay, it's either red or white. And then the next ball's taken out, it's either red or white, red or white. So the outcomes are red, 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 white, white, red, white, white. But these 4 outcomes are not a quarter, because we don't have an even number of both balls. So let's go back and put probabilities. Okay, we've got 4 balls and 3 balls, so we've got 7 balls altogether. So the chance of being a red is 4 sevenths. The chance of being white is 3 sevenths. And then because we're putting the ball back in again, then we've still got 7 balls and 3 whites, 4 and 3. So we're putting the ball back in, so that means that we've still got the same number to start with. And so we've got 4 over 7 times 4 over 7 equals 16 over 49. 4 over 7 times 3 over 7 equals 12 over 49. 3 over 7 times 4 over 7 equals 12 over 49. 3 over 7 times 3 over 7 equals 9 over 49. And then those numbers add up to 1. So let's just go through how we got those numbers again. So the first one, 4 times 7 times 4 times 7 is the first branch. And then to get the next one, I've got 4 over 7 times 3 over 7, and it gives me that branch. And then we switch down, 3 over 7 times 4 over 7 gives me that branch. And finally, 3 over 7 times 3 over 7 gives me that branch. Okay. So we're looking at putting not only outcomes but also putting fractions. So just don't forget, just because we had outcomes early with tree diagrams, we said there's 4 outcomes, it's all a quarter. Because these aren't all even numbers, evenly distributed, then we don't have quarters. Okay. So there's not a worksheet on that, but you'll be practicing that skill through the exercises coming up. Thanks.